Hey everybody, the purpose of this video is to help you get through problem 2.13.18 in the Collaborative Statistics textbook. Tricky to say. You remember this one from, we did it I think in the Measures of Center, or maybe in the Intro to Prob and Stat. I can't remember. We did part of this problem before. This is going to tackle parts E and F. E and F. I also added in a part, I don't know, D.5 if you will. The first thing it asks you to do is to calculate the sample average, and I think I had you do that at some point. If I didn't, you're going to kind of want it. So the sample average is about 8,629 students-ish. The way to do this effectively, you can use your TI's one-var stats command. What I did was I copied and pasted the data from the PDF into an Excel spreadsheet, and then I used the text-to-columns data feature, which is in your week 3 primer quiz. I gave you a little video on how to do that. So by all means, take a look at that. That'll help you use Excel to do it as well. But anyway, however you do it, your average enrollment is going to be about 8,630 students, and your standard deviation is going to be about 7,000. It depends on how much precision you need. That's down to the nearest whole student. So again, remember what that means. If you look at the histogram that we created a couple sections back from this, the balance point of all 23 of those schools would be right around this number. And the plus or minus around that, which we'll get into more here, would be about that many students. Okay, now that's kind of the point of this, is to explain, understand what that means. Now, the first thing I did was I created a number line, and I dropped the average of 8,629 onto this number line. Then I went up and down 6,942 from that average. So this is up 6,942 from the average. This is down 6,942 from the average. Okay, what that is called, as you might remember, is one standard deviation. Apologies again. Okay, apologies again. There is the standard deviation, which is little s. S enrollment is hopefully not confusing. It just means the sample standard deviation of the enrollment. It's not synrollment. It's the sample standard. Let's make it bigger. The sample standard deviation of the enrollment. When you add and subtract that to the average, you create the range of values that is within one standard deviation of that average. Now, that has implications, as you remember from class. It's got the 68, 95, 99 property, the empirical rule. I don't care about any of that right now. That doesn't answer this question. All it does is it shows us the range of values that are termed one standard deviation. So basically, one standard deviation within one standard deviation are any enrollments from 1,687 students up to 15,571 students. That would be one standard deviation from mean. Okay? That's what that means. That's what that region is equal to. Cool so far? All right, great. Now, the question in part F, because D was calculate the average, E was calculate the sample standard deviation. F is a school with an enrollment of 8,000 would be how many standard deviations away from the mean? Okay, well, I'm going to drop that school onto our little graph here. 8,000 would be to the left of average. I'm going to slap it right here. 8,000. Now, it's definitely within one standard deviation, because one standard deviation runs the gamut from here up to here. So it is definitely within one standard deviation. And assuming I drew it correctly, it also appears to be within half a standard deviation. But that's not what the question asked. The question asked, how many standard deviations away is it from the mean? So this question is essentially asking us, if we were to construct this region right here, how many standard deviations is that? Well, think about it. From here down to here was one standard deviation, which was a distance of 6,942. 6,942 difference. Ask ourselves this, what's the distance here? Well, if this is 8,000, and that average is 8,629, the distance from the average down to 8,000 is technically negative 629, but I'll just call it positive, just for the sake of simplicity. We can adjust it later. So the distance from X bar to the data point 8,000 is just 629. So that's the raw distance, 629. But that doesn't mean anything, because we have to look at that as a percentage of a standard deviation. That's about 600, and a standard deviation is roughly 69. So we can actually say this-ish is about 10% of that. So this guy right here should be roughly 1/10 of this guy right here. Well, this distance represents one standard deviation down. This is roughly 10% of that. So to turn that into a number of standard deviations, you just take that bad boy and divide it by the standard deviation. So as far as this goes, number of standard deviations, you would, kind of out of board here, aren't I? That's okay, we'll make it work. Put it down here. Follow the blue marker. Your number of standard deviations is just simply going to be the 629 over the 6942 for reference. Which I'm getting about 10%. I think I Googled it. It's closer to 9%, 0.09. I called it about 10. So it's about 0.09 or 9% of a standard deviation. In other words, it's pretty close. If you want to give it a direction, you would say it's 0.09 or roughly 10% below, 10% of a standard deviation below average, if you want to give it like an actual direction as well. But there you go. All it is it's a matter of referencing it with respect to this value. You have to reference it with respect to this value. That's why this was one standard deviation, because the distance was 6,942 over the distance of 6,942. Two standard deviations would have to go out roughly, what is that, 13,900? You have to go out 13,900. 13,900 divided by that gives you 2. So it's all just a reference point to that 6,942. Hope that helped.